Lesson 1.2, Properties of Real Numbers. There are two objectives. The first is to graph and order real numbers, and then the second is to identify properties of real numbers. Okay, so real numbers can be broken up between rational and irrational. Alright, if it's rational, it can be broken up further or classified as an integer, a whole number, or a natural number. Alright, so what's a rational number? It's any number you can write as a fraction. So 1/2. It's also a number whose decimal form terminates or ends. So 1/8. If you plug in 1 divided by 8 into your calculator, you're going to get 0.125. Notice how that ends. So that's rational. Rational numbers also have repeating decimals. So 0.3 repeating, or 1/3. Integers. What are integers? They're the natural, they're the positive and negative counting numbers in 0. So for instance, -2, -1, 0, 1, 2, and so on are integers. Whole numbers. Whole numbers is a set of numbers that does not include the negative counting numbers. It just includes 0 and the positive counting. And then natural numbers do not include 0. They just include the positive counting numbers, 1, 2, 3, 4, and so on. Alright, irrational numbers. They have decimal representations that neither terminate nor repeat. So their decimal representations don't end. So the square root of 2, right, that equals 1.4142, and so on. It goes on and on. It doesn't end. It doesn't repeat. Pi. What does pi equal? Well, 3.1415, and that keeps going on. Square root of 10. All right. So any number, the square root of any number is irrational unless that number is a perfect square. So the square root of 4, that's not irrational because the square root of 4 is 2. All right, and so 2, as we'll see, that would be classified as a natural number. Okay, so in these next couple slides, they just summarize what I just said and what I went over in the graph. I will add that rational numbers can be abbreviated with a bold Q, and it kind of has like a double line there. Okay, here's that second slide. Integers, the abbreviation for integers is a double-barred Z. For whole numbers, it's a double-barred W. And for natural numbers, a double-barred N. And I just want to be clear, when I say counting numbers, so are the numbers like when you count to yourself, you say 1, 2, 3, 4, and so forth. Those are counting numbers. You wouldn't say 1, 1.5, 2, 2.5, 3. So like 1.5 is not a counting number. 2.5 is not a counting number. So I want to be clear there on what I mean. Okay, problem 1 I want to change to reflect what you're going to see on your homework. So I wrote 3 different examples, -2, 3/4, and square root of 25, and I want to classify these. Alright, so let's start with the first one, -2. How would you classify that number? Well, you'd ask yourself, can you write it as a fraction first off? And you can. So -2 can be written as -2/1. So you can write it as a fraction, so that means it's rational. Okay, is -2 an integer? So integers include the negative and positive counting numbers and 0. -2 is a negative counting number, so it is an integer. Whole numbers. Whole numbers include just 0 and the positive counting numbers. It does not include the negative counting numbers. So -2 is not a whole number. So the most specific classification of -2 is it being an integer. Alright, 3/4. 3/4 is written as a fraction, so we know that it's rational. Is it an integer? It is not, because it's not a positive or negative counting number in 0. So rational is the most specific classification, and we know that that's abbreviated as the kind of the double barred Q. Alright, the last one, square root of 25. So you may be tempted to say the square root of 25 is irrational, because remember we said, pretty much the square root of any number is irrational, unless though that number is a perfect square like 25. The square root of 25 is 5. So so we know it's 5. So can that be written as a fraction? Yes, it can. 5/1. So it's rational. Is it an integer? Yes, it's a positive counting number. Is it a whole number? Yep, because whole numbers include 0 and the positive countings. And it is also natural. Alright, so 5 would check all those boxes there. So the most specific classification is natural. And you're gonna get a lot of practice on this in your homework. Okay, in problem 2, graphing numbers on the number line. Alright, so this is pretty straightforward. You're given -5/2, the square root of 2, and 2.6 repeating. So what I would do is write every single one of these as a decimal, and then go ahead and order them on the number line. So -5/2 is the same thing as -2.5. Square root of 2, we said earlier that that's approximately 1.41, and then 2.6 repeating is already written as a decimal. All right, so if we were to put these on the number line, let's label this -3, -2, -1, 0, 1, 2, and 3. So -2.5 be right here, so -5/2. Square root of 2 is 1.41, so it's almost between 1 and 2. And then 2.6 repeating is just past the halfway point between 2 and 3. Alright, and so that's how you do problem 2. Alright, example problem 3, ordering real numbers. So how do the square root of 17 and 3.8 compare? Use greater than or less than symbols. Again, go ahead and convert into decimal form. So if you type in the square root of 17 in your calculator, you'll get approximately 4.123. How does that compare to 3.8? So let's write both. So 4.123, and then let's write 3.8. Alright, so which one is bigger? Well, 4.123 is bigger, so we're going to make sure that the open end of that inequality sign faces towards it. So this would be your answer for problem 3. Okay, the next slide. The opposite or additive inverse of any number a is negative a. So when we talk about opposites, what's the opposite of 3? Negative 3. What's the opposite of negative 10? 10. Alright, so that's what an opposite is. The sum of a number and its opposite is 0, and that we call that the additive identity. So if you take two opposites and you add them together, you get 0. And you can see that in the example. 12 plus negative 12 gives you 0. The reciprocal or multiplicative inverse of any non-zero number a is 1 over a. The product of a number and its reciprocal is 1. And this is the multiplicative identity. So the reciprocal of 8. So 8 can be written as a fraction as 8 over 1. So the reciprocal means you would flip these. So 1/8 is the reciprocal of 8. Notice when you multiply those two together you get 1. In the same way, negative 5. Write that as a fraction. Negative 5 over 1. The reciprocal, if we were to flip top and bottom, would be negative 1/5. When you multiply those together again, you're going to get 1. Okay, the next slide just lists the properties of real numbers, and you should be familiar with these from prior math classes. So that's just there for your reference. Okay, problem 4. We're going to identify the properties of real numbers that we just went over in the last slide. So which property does the equation illustrate? So in A, we have negative 2/3 times negative 3/2. Now notice when you multiply those together, you get 1. So because the product of the numbers is 1, the property is the inverse property of multiplication. And then for part B, notice the difference between the left-hand side of the equal sign and the right-hand side. The equation reorders 3 and 4. So the order is changing in which we're multiplying the numbers. And that shows the commutative property. And it's the commutative property of multiplication because that's the operation that's going on in that particular problem. All right, so that wraps up the lesson. Again, the big thing that we're going to pull out of 1.2 is how to classify real numbers. So example 1, that's going to be super big and going to be the primary focus of our homework.